Hello, I am Oliver Jessup, and you saw the title. I'm building a lightsaber. Well, I've already built the lightsaber, but this is the first episode in a series of videos where I talk about the process I went through to make this lightsaber. This first video is about the basic concept of the lightsaber and the initial planning and designing that I went through to bring it into existence. So anyway, I wanted this lightsaber to be like a sort of movie prop that would give me like really physically realistic lightsaber blade interactions, which would save me from having to do VFX because obviously spending 3 years designing a completely new, never been done before lightsaber is way easier than doing basic VFX.
Basically, how I want this lightsaber to work is say something comes in contact with the blade, I want the contact point and the surrounding area of the blade to light up bright white to signify that something is in contact. Note that this is different from NeoPixel tip drag and flash and clash because it can detect contact anywhere along the blade, not just the end. It seems pretty simple, but it took me a long time to figure out the best way to detect if and where something was contacting the blade. I thought of using force sensors scattered along the length of the blade, capacitive or resistive touch sensors, or even vibration sensors to detect disturbances. But the most feasible and reliable method of detecting blade contact that I found was to place a ring of time-of-flight distance sensors around the bottom of the blade. Basically, how these things work is they shoot out an infrared laser which travels until it hits an object. The laser then reflects off the object and returns to the sensor where it is detected by a photoresistor. The sensor measures the time it takes for the light to reach the object and return, which then can be used to determine how far away the object is. Well, okay, the laser that it emits is less of a laser and more of a cone, and the measurements can be affected by the surface properties of the object, such as reflectance, roughness, and color, but don't worry about any of that. By placing the sensor at the bottom of the blade, when an object comes into view of the sensor, I can determine how far along the blade that object is, and turn up the brightness of the LEDs at that point. Here's a clip of me testing out the basic concept.
Now, the lightsaber I'm talking about in this video is actually the third and final lightsaber prototype of its kind. This this is actually the first prototype which has seen better days, but it was a really good test bed for me to be able to test the concept and figure out the best components to use in all of that. To detect blade contact, I used eight off-the-shelf VL530X proximity sensors screwed onto the rim at the end of the hilt. I also used 8 LED strips along a chrome-plated inner tube, which is this really wasn't a good design choice because it made the blade super thick and really heavy, and it was way too demanding on the power supply. But anyway, this is the second prototype of the lightsaber, which it actually did work, but it was really thick and bulky, and there's still so many things that I really want to improve on.
The electronics that I used were pretty much all off the shelf as well, which made it really janky and inefficient. I did make a custom PCB though to hold all four VL53L1X sensors, which helped me keep the hilt rim as small as possible.
This third and final prototype is building off all the successes and failures of the previous two lightsaber prototypes, which hopefully means it's going to be the lightest and most robust lightsaber that I have made so far. Based on these previous two prototypes, I think it's pretty good to come up with some goals for this third and final prototype.
First, I obviously want this lightsaber to have contact detection functionality. I also want it to be CNC milled out of aluminum instead of 3D printed like the previous prototypes were. I want it to have Bluetooth functionality to connect to a custom app to remotely control its color and other settings. And finally, I want it to be smaller, lighter, and more compact than previous prototypes.
So with that, it's time to design this lightsaber. And the most important thing is obviously the aesthetics of the lightsaber.
So I went on a quick Google search to come up with some ideas. I ended up finding a few images of a lightsaber called the Star Killer, which had an opening in the side so that the lightsaber crystal was exposed, which was something that I really wanted to put in my own design. I also really like the design of the bottom of Obi-Wan's hilt, so I decided that I would make my design a hybrid of these two lightsabers. With this inspiration, I came up with a 2-scale sketch of the final lightsaber design.
This sketch includes the opening in the side for the exposed crystal. But instead of putting a crystal in here though, I decided to extend the blade further down into the hilt and add LEDs here so that the blade light could be emitted out the side through these ribs. And these ribs were added to give the hilt some structure and also to be able to hold the blade more securely into the hilt. This whole portion here along the emitter end would be aesthetic components that are slid down on top of the structural section and are then held down by 6 machine screws. This lower section here would house all the electronics for the lightsaber, including the speaker and the ESP32. I also wanted the butt of the lightsaber to be able to be screwed off so that I could have easy access to all of the electronics. Finally, this portion of the electronics bay would be indented so that some copper wire could be wound around it for aesthetic purposes. I will talk more about all of this in the next episode though, which is about actually manufacturing all of these different parts. As I said before, I wanted to make this lightsaber out of like CNC aluminum because the previous 2 lightsabers I had made were both 3D printed out of PLA or ABS and then sanded and then painted with rubber buff to give it like a metallic appearance. But I really didn't like the finish that this ended up with, and it didn't feel way like real metal, which is something I want for the third design. So that's why I'm going with CNCing it out of aluminum. The added benefits of aluminum are also that it gives me like many different options of finishing the part. Like I can electroplate it or I can anodize it, and it just gives me a whole lot more versatility in the actual design of this lightsaber. And the added benefit as well of aluminum is that it makes the hilt a lot heavier, which is really good in balancing the lightsaber, which is a problem with the previous designs because they just weren't balanced that well. The blade was super heavy and the hilt was super light. It just wasn't great. So yeah, aluminum helps me with that. And apart from the structural sections of this lightsaber, I also have to think about the electronics that I'm going to use to control it. I'd experimented with many different control boards in the previous 2 lightsaber prototypes, such as Arduinos, Raspberry Pi Picos, and Teensy boards, but I found that for this design, an ESP32 would give me all the functionality and processing power that I needed. ESP32 would also allow me to use Bluetooth to connect to my phone so that I can control the colors and settings of the lightsaber, all from an app, which is 10,000 times better than a single button control, which is what all my previous lightsabers used. The lightsaber design also requires a gyroscope, a battery monitor, audio codecs, and a speaker. And the time of flight distance sensors that I settled on were VL53 L5CX sensors that had a variable field of view, which would give me way more ability to adjust viewing angles and laser range later on in the programming stage. Basically, that's the super high level overview of all the electronics and things that are going into this lightsaber. But I will go more in depth about the actual designing and manufacturing of all the PCBs and other electronic systems in the third episode. So that brings us to the end of this episode on the designing of this lightsaber. The next episode will be about cutting up all the sketches I did and actually manufacturing all the parts for it. So with that, I am Oliver Jessup. Thanks for watching.